All right, we're going to do a test 4 practice problem from fall 22. It was the last question on the test. And I noticed something here. This reaction here, I don't think we got to it. Yes, we did get to it. We did. I'm glad. So that was the SOCl2. And what do you need to know here? Anything? Just the mechanism. But over here, you have to do an analysis, or else you won't give me the right mechanism. So yours is going to start with some reaction, and then another reaction with lots of products. And typically, this one's going to be the SN1 analysis, but I'm going to prove it to you. This is a secondary RX. Here's my analysis. So you don't know SN1 or SN2, right? You can't give me the right mechanism until you figure out which mechanism to use. This is a moderate nu. What's that mean? What's your conclusion for moderate nu? Moderate nu. That's another SN1 or SN2, I don't know. If you're moderate, you're not pushing the limit towards one side or the other, in the middle, right? Where's the solvent? I don't see it. What's going on? Well, the solvent is also the nu. Is HN methyl twice polar protic. You know how I know it's polar protic? It has H bonded to N. If you have H bonded to N or H bonded to O, you are a polar protic solvent, end of story. If you're a polar protic solvent, you favor SN1 processes. Whenever there's an SN1 process, there's also a minor E1 process. E makes what kind of molecules? Elimination always makes what kind of molecules? They have a new pi. In every molecule, A, B, C, D, E, F, G, and H, the leaving group has done what leaving groups do. What is that? Leave. Please don't have the leaving group in your products ever. I see it every semester. I have no idea where it comes from, but it still keeps happening. Maybe if I say it during a lecture that I don't want to see it, something will help. Okay. So the ones on the far right are all eliminations. You know that? They have new pi bond. And the ones on the left are substitution. They have the nucleophile in them. Substitution, elimination, polar protic SN1. I need to see SN1. What's the, oh, that's not a highlighter. There was an eraser. What's the first step in your SN1? I'm going to start over on the right side. It's more fun. Then you can do that. Say you're totally flummoxed on the first one. You don't know what to do. Start on the second one. Most of the points are there anyway. You do not have to do the first one to get full credit on the second one. So what do you do first? Somebody said something. I heard it. I liked it. Leaving group leaves with its electrons. That's the whole point for that arrow, everybody. Don't leave it off. You better draw me this cation. You get a point for it. You can go for. This is not a nomenclature question. You can write pH. Secondary cation that can definitely improve. But this version I'm going to use to make product A. Tell me how to do it. I know that's kind of wild. You're almost there. How do I get that to be product A? Just tell me where my arrow starts and where it ends, and we can be done with product A. Starts lone pair on nitrogen. I'll do what you said. You said start on nitrogen. You're going to lose a quarter point for doing this. You just lost a quarter point. Oops. I did exactly what you said, though. You said start on nitrogen. No, I need a pair of electrons on nitrogen. That gets you a point. I almost went through the cation, didn't it? ends at the carbon. You're going to need at least one more copy of this carbocation. So please copy the carbocation. You might have to do it multiple times. You got multiple products. I think I can do directly product E from here. Talk to me how to do the elimination to get there. How do you know it's an elimination? There's a new pi bond. Where's the alpha letter? It's where there used to be a leaving group. Where are you allowed to remove an H from? Where must you remove an H from to do the E1 mechanism? Beta. Now, if you go up here, there's no H. You can't remove an H when there isn't one. But I see a product here where that's beta. That's beta. Put the H on, please. What's going to take the H off? Well, your nucleophile likes being a nucleophile most of the time, but occasionally it can be a base. Grab H. I need one more arrow. Tell me where it starts and where it ends. On the sigma bond, it ends between alpha and beta. Starts on the sigma, ends between alpha and beta, end of story. So these mechanisms are not hard, are they? You're liking this page now. You got some points already. Do you want to talk to me about product B? Something moved in product B. Moved from where? Moved from the cation we've been using all the time. You're going to need another copy. Just make another copy. Well, let's try to copy it the same way. Look at product B and tell me what moved. I want the name of the group that moved. The vinyl. The vinyl's on the second carbon here. Move it. You're going to make a wonderful cation. The second best possible cation on this page. Second best cation on this page. Secondary benzylic. How stable is that? 3.5 degrees. That's better than the secondary cation that you made here. So if you had to choose major, minor right now, I'm going with the product that comes from this. And this is going to go to B. I don't want to cross arrows too much. So I'm using these letters that are up there. And I need an arrow from the dimethylamine. And that gives B, doesn't it? Give me a copy of the cation for F. So instead of doing the substitution, I need the elimination. I just drew it a little better this time. I need the double bond between this alpha position. This is the new alpha because that's the cation. Isn't there an H on beta here that would give me product F? Okay, so I want to keep these guys separate. And this is going to go to F in black. Need the amine again. Yeah, not bad. You see products C and G? I bet you can tell me what moved in those. You got to go back to this position here. Phenyl. Phenyl's got to move. So, you know what I'm going to do? You're not going to like it. They say, wait, they're not equal. Yeah, they are. You're looking at it from a different angle. They're still equal. I just wanted, you know, I wanted the rearrangement to look exactly the same as the one above it. And what you got? You got a nice secondary allylic. Almost. Well, about the same stability as the one above it. You add 1.5 degree signs, whether you're allylic or benzylic. And you're gonna need a copy of that one to get to G. I don't want G to disappear off the screen. Things are a little tight. I don't like it. Go smaller. So I need an equal here. And I got my blue. Whoa. And this is going to be, to get to G, you need this H. And to get to C, you just got to have your amine again. We're getting points for doing the same stuff over and over again. We're loving it. And then this one goes to G. What's going to grab that H? Your dimethylamine. Sigma begets pi. And the absolute best combination, best product is D. What moved to get D? Here's what you're moving from. Don't move the phenyl from this carbon. Don't move the vinyl from this carbon. What's the only other option from this carbon towards the cation? I moved this group. I moved the phenyl group. What's the only group I haven't moved? Propyl. You're going to move the propyl to make the best cation you've seen all semester. Yeah. The best cation all semester. What do you got? On the cation, we have what's called an allylic position and a benzylic position. And it's amazing. There's the propyl group right here. You want to see it? There it is. 1, 2, 3. This is tertiary allylic and benzylic. I want a degree sign that summarizes the stability with just a number. Nope, that would be just allylic or just benzylic, not both. 6 degrees of separation. Google that. Just Google that expression. 6 degrees of separation. I won't get into it. It's too old for you guys. You don't even know who Kevin Bacon is anymore. So what do we got? We got tertiary allylic benzyl. This is whatever the product is going to be after this is major. Okay. Do we have to describe why? I don't remember. So this product you're about to draw, well, you don't have to draw it. You got it labeled. It's called D. Is major. And don't talk to me about the stability of D. Some of you tried that last test. It's not about the stability of the product itself. It's about the stability of the intermediate made in the rate determining step. Making cations is rate determining. The fastest cation will be the most stable. Which one's the most stable? One that has roughly 6 degrees of stability. So even if this question's not asking for this, I'm giving it. You put your answer here. This C plus has the most stability. It's got tertiary, which gives hyperconjugation, right? It's got equally important benzylic and allylic give resonance. That's even, well, I think it's more important than hyperconjugation. Okay, and we need another copy of that cation to make product G, I believe. If that's alpha, then that makes this beta, and this should give product G. If I take the H off, that's not a good looking G. H, N, lone pair methyl methyl. Grab H, sigma become, whoa, you can't go there. Yes, you can. Sorry, we went there. We can't go there. This G, I'm sorry? Oh, yeah, we did. Yeah, we did a G. It's H, yeah. And the double bonds right after the phenyl, and there's a vinyl on the end. Vinyl on the end, right after the phenyl. Yeah, that's not a G, it's H. And thank you for pointing that out. And consistency, make it black. And let's big picture, see what we got. We weren't even asked, oh yeah, we were asked to explain, good. Circle the major product, we circled one. Explain, do not explain on that, explain on this. This C plus has the most stability. Yeah. Blue box on it. The circle and the explanation counts for 4 points. Well, that circle's not the circle. This is the circle. I'm just making sure all this, you understand. I'm talking about that cation. And we're good? End of song. No, it's not end of song. We didn't do that first mechanism, did we? Okay. I think what I'm going to do is the first mechanism over on a new page, on a new video, and just break it up a little bit.